back. Yeah? Excellent. I'm waiting for the last people to find their seats. Hello, everybody. Is the sound okay? I hear a little bit of an echo, but you're good. Okay. Well, welcome everybody to this seminar on 100% green production and, as you can tell, agrobotics in high-tech greenhouses. We have exciting news for you guys today, so please join us into an interesting ride. I first gonna introduce to you who will be speaking today on 100% green production and the future for horticulture. I am Charlotte Langerak. I am CEO with Viscon Group. Adesh Shah, I brought Adesh. He is my strategic innovation engineer, and he will be speaking on the robots we today launched. I brought Ton van Dalen. I'm very proud he's here because we've been, as a sector, working on 100% green production for a while now. And Ton is basically our flagship coordinator, I'd like to say. So he will speak on why we, as Dutch horticulture, are taking an interest in being best of class. Also, I'd like to introduce Rob. Rob is our head grower at Bright, and the robot we introduced today is being tested and co-developed with Rob, so we're very proud. He wants to testify to the fact it actually works. And also, Valeria is our killer CEO of Fermata. Fermata is a company which develops AI models for scouting, which is something we hear a lot about, but we now have proof of concept. It actually works. So this is the team we're gonna discuss today, how we're gonna move towards 100% green. I'd like to introduce you first to our vision on sustainable horticulture. Then I'll give the word to Ton, who'll speak on behalf of the sector, and then the rest of the team will speak on the actual innovation we did to make 100% green production available. We at Viscon, we say we envision a world in which people, plants, and animals can thrive. We also believe that a thriving world, a thriving planet, and thriving people can actually come to existence when we also have a very sustainable food production system. We also believe that a very sustainable food production system needs some ephemeralization. You might not know what that is, so I'll explain you a little bit about it. Ephemeralization is a term coined by Buckminster Fuller. He was a journalist in the days that Henry Ford first opened his new factory for the production of cars. And then, at that moment, it was the first time usage of conveyor belts. And in those days, they were so mesmerized about the idea of producing in factories with that kind of automation. He said, basically amazed, wow, if we keep doing this, we'll be able to produce way more with way less until we do everything with nothing. And we as an automation company were obviously inspired by this term. So we always say, if you want a sustainable food system in the world, you need ephemeralization. We need to be able to produce more food with less resources. At this point in time, we are doing already a really good job in producing food on a sustainable way. We believe that the Dutch model, where we grow food in greenhouses very sustainably, is a really great solution for sustainable food production. However, still, there's a lot of hunger in the world. Still, a lot of people don't have a healthy diet, and still a lot of food is wasted. So we also believe we need to keep rethinking how we work with this system. A short movie to give you a little bit of a feel of what we think is part of that solution.
In a world filled with global challenges, we envision a world where people, plants, and animals not only survive, but thrive. But how do we make this vision a reality? In a landscape dominated by urgent concerns, it's about understanding the intricate web of challenges and collaborating across sectors. Monumental problems have historically sparked monumental solutions. Human creativity and innovation have slashed poverty rates and improved countless lives. It's about intense focus, intense passion, and intense drive. Enter eco-modernism, the answer to a critical challenge: food availability for a growing population. Intensive farming can provide a sustainable way to feed billions, sparing land for both nature and agriculture. At Viscon, we're not just an agri-food company, we're architects of a thriving future. Our technology focuses on creating more with less. Less water, less waste, less pesticides, less energy. From cultivating young plants to rearing insects for livestock feed, our solutions contribute to sustainable abundance. In a world of challenges, we believe that through innovation and collaboration, we can create a future with more using less. We want to make the food supply chain more sustainable without sacrificing availability and welfare, creating sustainable abundance through innovative food production. This is the thriving way.
So that's our vision. We believe with the right innovations, we can keep improving on the current food systems to create more food with less resources. And one of the most important issues we still have as the sector is that we all aim for producing foods with less and less pesticides until we're 100% green. This is very important for the growth of our sector and for a sustainable footprint. This is why I'd like to give the word to Ton van Dalen.
Thank you.
There you go.
I have to press here, huh?
De groene.
Oh, the green. Okay. Well, Charlotte, thank you for the invitation, and I'm very honored. Well, you are introducing your robot today, so that's very nice that I'm here and that I'm also a part of the introduction of your robot. Thank you very much. I want to tell you something about the project that we do. We call it 100% green cultivation, and we do that because we see the world changing. We see more and more that the society is becoming critical about the use of pesticide, and they want to have a healthy and also a sustainable food system. And that's where we, in Holland, we are with the growers, we are working to come to that system. That's why we started the 100% green project, and we do that with the Federation of Fruit Vegetables in Holland. That are 5 producers organizations that working together, and it is a strategic collaboration between those 5 organizations. And when you look at these producers organizations, then you have Growers United, Harvest House, Oxen Growers, Greenery and Zon. And when you look at how much area we represent 3,100 hectares of glasshouses in Holland. That's almost 85% of the Dutch greenhouses. And that's also about 300 farms that working together. And they are growing like tomatoes, cucumbers, zucchinis, eggplants and peppers. Besides earlier mentioned, we also had in 2023 a report of the University of Wageningen. And when you look at this report, you see a declining of active ingredients. And that was also a worry for us as organization and also for the growers. When you look, for example, it is a little bit small words here, but when you look, for example, the active ingredient for aphids, in 2023 we had 8 active ingredients, and when we look in 2027 we only have 1, perhaps nothing at all. And that means that we have a problem to control this disease. So when you look at our project, we started it but with a goal, because you have a goal to come to the horizon, the stip. We call it the stip on the horizon. But when you look at it, it has to be a profitable system. And we are looking for green, biological and also technological innovation to come to that 100% green project. So when you look here in Amsterdam, you see a lot of technical innovations. So that is very good to see, and that will help the growers to come to that 100% project. When we started the project, most of the time when you look at research stations, they do it on small area. But we find 7 growers with a very good motivation to come to the 100% project. And these are the growers in Holland that are working now to use less chemicals in their system. There is also mentioned Bright. Bright is here, so he will also tell about what he see in his growing in the greenhouse, and also he will tell more about the robot they are using over there. We also work together with Botany. And Botany is a research station. We do there also products without chemicals, and also we look at the fertilizers with different kind of substrates to see if there is also a solution to come to the solution without chemicals. We also have knowledge partners in this project, Koppert, Van Iperen, Rijkswaan, Let's Grow, and Van de Knaap, and they also help us to come to a solution. We do the project for 3 years, and we started in 2024. So when you look at the result in 24, we see that we have a decrease of the active substance, an average decrease of the active substance uses per hectare of 70%. So you see that there is a lot of, when you look at the use of chemicals, there is a lot of solutions possible. But this is only 1 year, and it was also a year when we have less disease pressure. So we are very curious what will happen this year, and also, of course, what will happen in 2026. But when you look at the pilot, and here you see everything that is green, we have a solution for the disease. But everything that is red and double red, we call it a red flag, we have to find a solution. And that's why we're working together with suppliers, and we're working also together with research stations to find the solutions for the red flags. But as you can see, we still have a lot to solve to come to the 100% green growing. When you look at the plant in the greenhouse, and this is a quadrant that is made by Delphi, you have 4 quadrants to look to the plants. And now we are working, the first year we work especially with the biological in the quadrant 1, the biological control, the hygiene, a little bit of the genetics, and a little bit of the biostimulants. I have to be a little bit quiet. This year we're working more on the second quadrant. We are looking at the substrate, the different kind of fertilizers, different kind of technology, and also different kind of material. And when we are going in the third year, we are going to work more on the other side. And when you want to come to a resilient growing system, you have to work to the whole system. Like in the, let's say 10 years ago, when you have a disease, you just spray a chemical and then you had a solution. And when you want to find a solution now, you have to look to all this, to the whole system of the plant to come to the solution. So that's why it's more and more becoming, for the growers, it's more and more becoming a little bit difficult. So how you can find all the solution, and that's why it's good that the total, we call it the high-tech ecosystem, is working together to find the solutions. And also, here is this just a little word, but the mindset of the growers, but also of the suppliers, of everyone that is working in the horticulture, you have to go to make a mindset to come to this system. And so it is good that we are working now on it, and also that we get the support of, let's say, Viscon to come to robotization of, in this case, scouting. What that will help us to come to the total solution. And when you look at to the scouting robots, you can have earlier information, and the earlier information on all the data you have, you can also earlier act to come and to make an end of the disease. But also, when you look at the robot, it will help you to reduce labor costs, but the robot is working 22 hours per day. Charlotte told me. So 22 hours a day, now, well, that's not possible for a human being. So if the robot is working 22 hours a day and you can collect all the data, that will help you as a grower to make your decisions. So I'm very happy that that when you look at the robotization here in the horticulture and also what you see over here in Amsterdam, that's happening in Holland, and that all those automatization will help the growers to come to the 100% green cultivation. So thank you very much.
Je krijgt een eigen applaus, Ton. Thank you so much, Ton. And we're so proud at the corporations who work together with the Dutch ecosystem to actually get these improvements already. So thank you so much for speaking into this. I'd like to give the word for the next part of the presentation to Adesh.
Hello, everyone. Here we will talk about the robot itself, what Ton also briefly introduced to us. So I will give a brief introduction to the robot. Valeria will talk about Fermata and the model from Fermata, and Rob will give his experience of the robot in the greenhouse. First, I want to take an insight on why we built a robot and what was the idea about it. We call it EVA. It's not just a cute name. It's a efemalized Viscon Agrobotics. It's something that we did extensive market research, talked to Ton, FEO, a lot of growers like Rob, to actually figure out what is the need and what they need to be 100% green. And that was the guiding principles of making that robot. The first thing was they wanted to have active scouting, which includes more frequency, more coverage, and also focusing on more level, how the level of scouting looks like. Then the second part they wanted was to have early detection of pests so they can control it, because when you are using biologicals only, you need to detect the pest earlier because you can release your biologicals accordingly and plan it very well. So that also was a second guiding principle. This third was it should work in a greenhouse. I don't know if you know how a greenhouse environment looks like, but it is very chaotic. It is barely having any space for anything to move. There's always a lot of activities going on. So you want a robot that can drive in a greenhouse, fully autonomous, so that it can work and be a part of the greenhouse. And the final thing was, obviously, you do all this to get peace of mind, and that was the whole goal, to make this robot. I'm going to show you quickly how the robot looks like. It's a render, but you can actually come to our booth, the Viscon booth, to see the robot running and ask any questions you want to ask. But I'm going to quickly go through the robot itself. So we have lights and cameras. We try to cover the whole crop from top to bottom, from the tomato to the head. It has 4 cameras, and it can take images as small as 0.012 mm and detect pests in day and night conditions. Then we wanted to make sure that it can work in a greenhouse. So if it stops, it does something. The growers and also the workers in the greenhouse should know what the robot is doing and why it is doing that. So that's why we wanted to have very intuitive design with lights and everything. We wanted to have active obstacle detection because, as I mentioned, there's a lot of movement in the greenhouse, but also sometimes the trolleys are planned in the rows where they just keep the trolleys and then they plan it for the next day. You don't want the robot to crash into a trolley, obviously, but what we do is we go to the trolley, we detect the trolley, we drive back, register that row in the map that it is not scouted yet, and then next day we pick it up again from next time. And finally, we call that we can do autonomous level 4. Everyone has this question, what does level 4 mean? Basically, we took inspiration from the automobile industry because everyone has different definition of autonomous. So what we normally can do and what we mean by autonomous level 4 is we can do obstacle detection, we can drive to an arbitrary location, we can also charge ourselves, and that's what we mean by level 4, and localization and navigation. So we also localize globally in the greenhouse, map of the greenhouse, so we know exactly where the robot is. And if you switch off the robot and restart it at an arbitrary location, we know exactly where we are in the greenhouse, and that's what we call level 4 autonomy. And we don't do this all alone. We do it with a lot of features on the robot. So we do, first is, as I said, autonomous level. Then we have high positional accuracy, because the whole idea is you don't want to see the pest today itself, but you want to trace it back over time, after day over day. If you do a treatment and release a biological in an area, you want to make sure that you trace it back to see if that biological actually worked in a greenhouse or the pest pressure moved around. So we want to make sure that you can have positional accuracy, very high accuracy, so that you can also trace back your insect and pest pressure. The next is we wanted to have day and night driving. This was very interesting setup. Firstly, we start thinking of day and night driving from a robot's coverage point of view, but then slowly when we went into the development and we realized that night driving is actually very interesting for the growers also, because there is no scouts in the night, and you see a lot of information in the night which is not possible to see in the morning, and that's why it also becomes a very interesting feature for the robot. And with all this, we try to cover 4.5 to 4.58 hectares. It strongly depends on your greenhouse itself, because we can drive, as naturally we can drive faster on the rails, and due to regulations, we can drive slower on the concrete floor. So if you have longer rails, we cover more, and that's how it works. And we have 22 hours of runtime. We have 2 hours of downtime, because if we cover 4.5 hectares, we collect almost 2 terabytes of data that needs to be transferred, needs to be processed, needs to be taken care of, and that's all done by Fermata. And then finally, we give a dashboard at the end of the day, because this is all cool to collect data, but the data should be converted into information, and that's what we provide, which is always 1 day old information. And to make sure that we have a high uptime, we have swappable batteries, so you can just swap the batteries just as your power drill, and you have uninterrupted performance of the robot. And with all this, I would just say, let's get to the more exciting part of Fermata.
Even more exciting.
Yes.
So we realized in developing this technology, we need everybody. So we need us as technology suppliers, we need all the growers, the corporations, we need all the information. We also have to realize with all technologies you see here at GreenTech, at this point, the technology that's being developed is so technologically complex that it really helps if you can focus on what you're actually good at and partner up with people who know what they're doing in their area. AI, everybody says AI, but at this point, AI gets a bad rep because we also see a lot of promises from AI which are not actually delivering. So we felt like we stick what we're good at, and we're going to work with somebody who has already delivered. So I'd like to introduce you to Valeria.
Thank you. Hello, everyone. So my name is Valeria. I'm the CEO and founder of Fermata, and we're an almost 6 years old company working on what we call the eyes of ag. So when we started 6 years ago, with the idea that we want to bring AI and computer vision to monitor plants' health. Unfortunately, back then it was not possible to deliver, like for software people like us, our technology in any way to the greenhouse because there were no robots that we could partner with and deliver this technology. So we were thinking what we can do to make AI, though, available to the growers. So, and what we did is came up with a pretty simple idea, is that we will be putting in the greenhouses just standard off-the-shelf security cameras, because that way we don't depend on anybody. And that's the product that has been in the market for a couple of years already. So what we do usually before EVA is that we put these kind of cameras, 10 cameras per hectare, and the cameras several times a day, zoom into every single plant that they see, take the pictures, process these pictures with our AI, and then the grower gets an app where he sees where and what has happened and gets the information about the pest pressure dynamics and how his treatments are affecting that pest and disease pressure, and can make the right IPM decisions. So you get obvious questions like that cameras cannot cover everything. That's correct, and we're not seeing the whole crop, but we thought that maybe this solution will be good enough. And it turned out that, yes, we still can bring pretty significant value to the grower, even with such a simple solution. So over these years, we have developed a system for detecting over 20 different issues, like all the basic pests, thrips, spider mites, whiteflies, aphids, diseases like botrytis, powdery mildew. We detect viruses, including TBRFV. We detect nutrient issues, mechanical damage. So all the problems that our growers over this period of time told us that are important for them. And you can see here on the slide some examples of these detections. So you can see rugose virus detected in tomato plant, a little whitefly sitting there on the stem of the tomato plant, powdery mildew that is just starting, spider mites damage, thrips damage, and some nutrient issues. So these are the screenshots from the app that our farmers are using, so real data from our customers. And you can see that even though we're using just the stationary cameras on the ceiling, we're actually getting very good resolution of images and are able to detect very small things. Pests themselves when they're visible, or symptoms of pests and diseases when this is the only thing that we can see. And why this is important, yeah, and what value can it bring. So we've been talking here a lot about how important is biological protection and that everybody wants to go 100% green, but of course, there is a question who's going to pay for it, right? Because biological protection is very expensive and it's a huge burden on the grower. So I wanted to share one of the case studies that we have built just recently with one of our grower Ridge farms in Canada. So this grower we started with working several months ago, and in the beginning of the season he didn't have any whiteflies present in his greenhouse. And of course his reps from the biological protection companies, like all his neighbors, were already releasing the beneficials from whiteflies, which were not there really yet. And the winter was cold, and he was not really willing to release the beneficials yet, but he was scared not to do that also, because what if it ruins his crop? So, and we switched on Fermata, and we noticed the first adult whiteflies in the greenhouse, and you can see one of the pictures here with the whitefly sitting actually underneath the leaf that we were seeing in his facility. And his decision was, because you're actually able to see whiteflies when I'm not seeing them, IPM manager is not seeing them, my sticky cards are completely clean, I would probably trust not releasing beneficials yet, because I know that I can trust you, and if there is a growth of population, then I will release them. So, and you can see here the chart that we were measuring for him with really low population of the adult whiteflies, and here you can also see the heat map where all the whiteflies were actually in one corner of the greenhouse where he just put sticky cards. So for this particular grower, 5 weeks of delay of release of beneficials that we were able to make happen with the detailed monitoring of the populations of whiteflies no one has seen with their eyes, we're able to save him over $25,000. Yeah? So, and this is where the ROI comes from, not just automation of scouting, but actually when you're going 100% green, make it actually profitable and reasonable for the farmer. So a lot of people trust us over these years on the market. So we work with seed companies like Syngenta and Bayer and helping them in the seed production stage. We are working with propagators, and we are working with large growers in different countries. We have customers on all continents. So why are we here then? So even though over the years we have collected an amazing data set, we have 500,000 of images that we have collected and labeled with an in-house agronomy team. We have 12 agronomists that work just on that task, making sure that we will create quality models because we have quality data. So we have over 20 different models for detection of pests, diseases, and viruses. We have customers in different countries, as I mentioned, and significant experience of actually making this data a product and deep understanding of why does grower need certain types of data. we still understand that that's not the perfect solution for vine crops in high-tech greenhouse environment. And when we just were in touch with Viscon first time with the idea of bringing our vision to the robot, I was super excited because it was clear what a huge added value with the robot we can bring on top of what we already have. So because with robot, we can have the holistic view of the plant, we can have much higher quality data, which we can use for many additional applications, and use it, like if someone already purchased the robot and generated this data, what else can we do with that but scouting? We get 100% coverage of greenhouses, which is not possible with the stationary cameras, and of course, endless opportunity for AI development using the same platform and creating more and more additional features on top of that. So because we have already all these models, we were running with Eva Robot at different greenhouses to collect additional data and make sure that our models perform well in these new conditions when we're collecting data from the robot. So Bright, unfortunately, didn't have many problems. So when we had unlimited opportunity for validating the models. So we have 5 models which we are confident are like commercial stage right now within the robot. And with our stationary camera solutions, we have case studies that show that we are saving to our growers up to 50% on their scouting, 30% on their crop losses, and minimum 25% on their crop protection. And we believe that with robotic solution, the numbers will be even more impressive. So, and that's why we're working on further image collection on the robot to make it happen and make it available on robot as soon as possible, while working with Bright, collecting data in different lighting conditions with the robot, and training and deploying these models on the robot and building case studies to prove the numbers that we have in this new environment. So, who wants to describe this? Me? Okay. So this is the recording of the dashboard that Viscon team built for Eva, where you can see, similar as you saw in our report, the heat maps with the areas of presence of different pests and diseases that we're detecting. You can open up a detection, you can validate the images with your own eyes and make sure that you can trust us. And then you can make the decisions for beneficials release or spot spraying if you decide to do that using the data in the dashboard. So our main vision is that you will be able to use spot applications instead of doing blanket applications, which is very clear from this heat maps, and that we'll be able to stay at the hotspot level as long as possible, generating ROI by that.
Thank you so much.
Thank you, Charlotte.
Right? We're very happy because this is the dashboard US growers get. So you can actually see where in the greenhouse you have any pest or disease pressure. Press the button, a photo will pop up of your own greenhouse, what's happening there, and you could check yourself whether you want to treat it or not. And then 22 hours a day, your greenhouse gets scanned, 4.5 hectares in one day. You have all data you'd possibly want. And obviously, this is also, we will be building upon this data, because now you see your entire plant day and night. So you're also going to see way more information. Is your plant happy or not? And a lot of plants don't show disease yet, but if you can tell they're unhappy, you know something is going on. So many different opportunities will occur after this, is what we suspect. Rob, please join me. Because I'm a salesperson, you can tell. And Rob actually works in a greenhouse, so he can explain you everything about the robot live. So I'm going to take questions from you guys first. What would you want to know from somebody who's actually working with this technology to move towards 100% green? Oh, dat is een goed idee. Yeah. Who would want to ask a question to Rob? Don't worry, I have questions if you can't come up with one now. You can be critical, even cynical. Yeah, we have one question here from the front.
What's the level of accuracy you see one of these systems?
Just repeat it on the microphone. Thank you.
What's the level of accuracy that you see in one of these systems?
The accuracy, that's a technical question.
So I can answer it, or you mean so how small we can check?
Would you
Very good. Try again. Yeah.
Try it again.
Yeah.
Here we go. Here we are. So how accurate are the vision? Are the images that you're getting from the robot? Right. So is it 95% accurate? Is it accurate 99% of the time in terms of what it sees, and then you go and check and ensure that that's what's going on? I mean, is there a scale there? Is it accurate 50% of the time?
We have a WhatsApp group where they share their images. If they have a question for me, like, are you sure this is a whitefly? And the most things that I've seen from them, they are all accurate.
So what we can do is we can see up to 0.012 millimeters as in smallest, so it also means larvae and eggs. However, we have a confidence level. So we have a dashboard and it says pink. You know, we're not too sure. And it's bright red. We know we're 100% sure we have a problem. And we do that also by checking, hey, we see more of this problem in this area, so it's probably a whitefly. And if there's just the one in the entire greenhouse, we're going to be like, it might not be a whitefly. So you can actually also filter on confidence levels. Yeah. Any other questions? There's one.
So the gathering of information is very impressive. And then do you also support your customers with taking action on, let's say you detect a pest, do you also support them in trying to deal with that pest, or what does the sort of the follow-up action look like for the robot?
Absolutely not.
Yeah,
Okay,
and that's the right answer.
Okay,
But based on our experience, so you don't want to receive in the end just a piece of metal and access to the dashboard, right? So what you need to get is an experience and a service. So the way that we approach our customers, there is some kind of sound coming from here. Yeah. So the way that we approach this issue is that once we have weekly meetings with all our customers, right? So we spend like at least an hour together, and we make sure that everybody on the customer side work as a team. So if you have IPM expert, cooperative biobest rep, so your crop consultant, we make sure that all of these people are getting our data, understand our data, and take the right action. Because there is no ROI, if there was no right action taken. So we approach it more as like creating the ecosystem, creating the team, and putting the data in the center, but these people decide what to do.
Yeah, so we really stay away from advice. We detect, this is your problem. We have a problem. We detected it. Please be smart about it. That's what we do. Yeah. Maybe a quick question for Rob. Why is this development important for your daily operation, and why would you be investing so much time in it now?
Because I see the development of the robot. There's a good collaboration between the both companies and the growers to simulate all the different situations in a greenhouse, obstacles. If you have a new pest, you introduce it, and they work on it, and they make a new model. So it has endless possibilities, actually, and that's what I think it will improve even more.
So why would it have... so it has endless possibilities, but where has it most impact for you as a grower?
Just like Ton said, the possibilities of controlling pests are getting limited more and more. And when you use biologicals to control the pest, you don't have that much time. And if you find a pest at an earlier stage, you can target the pest way earlier, and it's way more successful.
So the early detection is most important for you as a grower?
Yeah, absolutely.
Okay, so we see a lot of innovations being coming to market currently. Why do you feel confident about this will work?
Yeah, just like I said, the team and it keeps on developing. That's why I think this one is better.
That's cool. You're part of the team. Any other questions from the audience at this point to anyone? Oh, there's more. Yeah.
All right. This is more of a technical question, but what is the coverage of a singular plant, for example? Is it like 80% of the plant is seen by the video cameras, or 90%?
Yeah, that's a really good question. Valeria, that's for you. Oh, no, Adesh.
It's mostly, we try to cover the whole plant. It also depends on how the grower wants to collect the data or also wants to see the plant. So right now, we have made sure the cameras are positioned as per Rob's input, basically, that this is where I see this kind of pest, this is where I see this kind of pest. And we always made sure the camera is a bit lower than that because we have a nice field of view then. and we mostly have a pole that can go up and down. So you can run the same row and cover like the plant, and then run it again, and lower the pole and run it again. So it depends on the grower how they want to use it. We try to keep the robot as flexible as possible.
All right, so one more question? Here up front. Yeah, thank you. Oh, sorry.
So I have a nursery, and it's not concrete floors, it's more of a ground cover in plastic.
Yeah.
So my question would be, first of all, why would you have a robot instead of just several cameras around? Because the robot, well, I assume it damages the floor a bit if it's plastic. How well does it work in that instance?
Oh, good question. So what we developed especially for high wire crops in Dutch high-tech greenhouses all have tube-rail. All different ones, of course, which we also engineered for. However, Fermata has many different options for a greenhouse like yourselves, which has stationary cameras.
Yeah, so this solution is specifically for high wire crops.
Yeah, which usually have the tube rails where you can ride on. Yeah. So, but there's also different solutions which do not even need a robot. Yeah, it will not work in a plastic greenhouse. Yeah. Thank you. I think we have 27 seconds left for one last question.
Two last questions.
I have a question for,
Yeah.
Sorry, for Rob. As a grower who's adopted the technology, like what's your experience been? Sorry, as a grower who's adopted, can you hear?
Yeah, it's good, yeah.
As a grower who's adopted the technology, what's your experience been, introducing this into your environment, and how have you used the data, and what's the sort of immediate benefits that you've seen?
We haven't been to the real big data yet, but during the tests, especially in the last few weeks, the steps that they made were big, like finding the pests that we also see as growers. And they see it in a lot of more places. And the heat map is more detailed than we have right now. So that's, yeah.
Great. All right. Well, thank you everybody also for your questions and your interest. We're available if you want to learn more. Also, well, I'd want to say Ton, but you don't have a booth, I think, here. So, no, this is all you get from Ton. So thank you very much for your interest, and we'd love to see you the rest of the show. Thank you.
Thank you.